It is one of the most intriguing questions in all of science: are we alone? With the launch of the James Webb Space Telescope, we might be closer than ever to answering this question. A recent study shared on a preprint server showed that the telescope could discover signs of atmospheres capable of supporting life on alien worlds beyond our solar system in only about 20 hours. A means of studying distant worlds is via the wobble method. As a planet orbits its host star, it tugs on that star ever so slightly with its gravity. This causes a tiny wobble, a subtle rocking back and forth that can be measured by using precision instruments. However, the transit method has proven to be the most robust so far. It's used for detecting and studying the properties of a planet via the dip in the brightness of its host star as the planet passes between it and us. But the James Webb Telescope will possibly transform exoplanet studies in the search for biosignatures in the atmospheres of alien worlds via transmission spectroscopy. It is the most basic technique for analyzing samples in the infrared. Light from the host star passes through the exoplanet to be registered by the James Webb Telescope's detector. For the first time in human history, we are on the verge of finding whether life exists elsewhere in the galaxy. I think there must be, even in the solar system. I would not be surprised if we find microbes on Mars or on some of the moons of Jupiter or Saturn where there's liquid water. The reason is, if you think about it, the reason I think that it's a guess is because if you look at the history of life on Earth, then so Earth formed and it was just a ball of rock, and almost as soon as it cooled down, we see evidence of life. So certainly 3.8 billion years ago, possibly even further back than that, we see evidence of life on Earth. Somewhere along the line, geochemistry, active geochemistry, became biochemistry on Earth, and we have some idea that if you get gradients of temperature and acid and alkaline, the conditions that are naturally present on the surface of oceans, then complex carbon chemistry spontaneously happens. So we know that life almost certainly began on Earth. I mean, the other option is it came from space or something like that, but it probably didn't. So that means that at least here, that happened, and we know that the conditions that led to the origin of life on Earth were present on Mars 3.8 to 4 billion years ago, and we know that they're present on Europa today. I don't see that there's anything special. Life is just chemistry, and the idea that geochemistry becomes biochemistry is not fanciful because it happened here. I think that given the same conditions, it would be surprising to me if the same thing didn't happen and that life begins. To test that is one of the great frontiers of science now. It's one of the great challenges, which is why another reason we're interested in Mars is because we know those conditions were there. We know there were what's called hydrothermal vent systems on the floors of oceans on Mars 3.8 or 4 billion years ago, so it would be good to know if what I've said is right. The way we find out is to find life or evidence of past life. There are about 300 million planets in our galaxy alone that might support life as we know it. By the sheer number of these planets, it can be argued that we are most likely not unique in the galaxy. However, even if life exists elsewhere, it can be expected that the vast majority of it will be simple organisms such as microbes. Of course, the most exciting life forms will be intelligent multicellular organisms such as us, but among the many attributes of life on Earth, intelligence is the rarest. All species of animals, land plants, and most fungi on Earth are multicellular, as are most algae, whereas few organisms are uniquely multicellular, like slime molds and social amoebae. Multicellular organisms arise in various ways, for example, by cell division or by aggregation of many single cells. But going from single-cell life to multicellular life forms is one thing, attaining intelligence is a different thing entirely. If the evolution of life on Earth reflects that of life in the galaxy, it can be argued intelligent civilizations are extremely rare. What we do know about Earth is that although life began, let's say, 3.8 billion years ago, it wasn't until around 600 million years ago or so, or maybe at most 700, that you see any complex multicellular organisms at all. So for something like 3 billion years, it was single-celled alone, and that's one of the reasons why I would guess if I had to guess, I would say that microbes would be common because life began very quickly on Earth, and I would be surprised to find it on Mars, but complex life, multicellular life, insects, plants, intelligence, I would guess would be very rare because it took so long on Earth to get there. A new analysis concludes that roughly half of the galaxy's sun-like stars host rocky worlds in habitable zones where liquid water could pool or flow over the planet's surfaces. Perhaps some of the rocky worlds are the home planets of distant alien civilizations. The Drake equation uses 7 factors to estimate the number of detectable civilizations in our galaxy. It considers variables such as the number of sun-like stars with planetary systems and the number of habitable planets in each of those systems. From there, it considers how often life evolves on worlds with the right conditions and how often those life forms ultimately develop detectable technologies. It took more than half a century for scientists to start pinning down how many planets could feasibly host life, but now there is an even harder question to answer: how often can extraterrestrials develop technologies that we can detect and the length of time such civilizations are detectable? Even if there were countless intelligent civilizations through the billions of years of the galaxy's evolution, we have no way of knowing about their existence if we don't have the right timing. If civilizations are common or even slightly common, then there should be civilizations ahead of us because there's been so much time. You imagine the timescales we've been around as a civilization, let's say 40,000 years. I don't know how long our civilization's been around. Let's say that the galaxy is pretty much as old as the universe, it's 13 billion years worth of time. So the idea that there are no civilizations arose, 100 million years ago, 200 million years ago, 1 billion years ago, and imagine what they'd be like if they'd survived. I mean, we've been around, we've had science for, let's say, since Newton or Copernicus, 500 years at most we've had. Look what we've done, we've gone beyond the solar system with Voyager, we've walked on the moon, we're about to go to Mars, I would think, so we're about to begin colonizing our own solar system. We've done that in 500 years, so imagine 1 million years. It's one of the arguments often used to say there aren't any civilizations out there in the galaxy. It's called the Fermi paradox because if you imagine a civilization that's 1 million years ahead of us, they should have written their presence across the sky by now. We should see them. If we survive 1 million years into the future, actually even a few thousand years into the future, we will be exploring the galaxy. We will have spacecraft that are going through with the stars, we will be doing it, so our signature will become visible, I'm sure, if we last. English science fiction writer Arthur C. Clarke once said, 2 possibilities exist, either we are alone in the universe or we are not. Both are equally terrifying. Imagine intelligent civilizations are prevalent throughout the lifespan of the galaxy. There had to be a first civilization asking, are we alone? Only in their case, the answer would be yes. Indeed terrifying when you think about it, but maybe that civilization is us. There are many people who believe we've already been visited by extraterrestrials, especially with recent UFO footage that has been circling on the internet over the past years. But scientifically speaking, the data shown so far does not qualify as extraordinary evidence for the extraordinary claim that we are definitely not alone. The Fermi paradox remains a problem regardless of how many people believe. It's extreme hubris for us to expect to find evidence of intelligent alien life when we cannot possibly imagine the most efficient ways an intelligent civilization millions of years ahead of us could traverse the galaxy. There is an argument as well that technology so advanced would be difficult for us to detect. I mean, we tend to think of starships that you can see the signature of, but actually maybe the civilization just becomes a nano-civilization because that's more efficient, it's a better way to do things. So it's possible, I suppose, that there are space probes all over the place that are so small and it's so efficient and use so little energy that we just don't see them. I suppose that is possible. Music, thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.